Harmonic motion. Harmonic motion is anything that goes back and forth over and over again, like ocean waves, sound waves, light waves, that type of thing. And in this figure number 2, this is the motion of a spring going back and forth. And sine and cosine graphs model harmonic motion. And you can see in the little picture of the spring going back and forth how it reaches a highest point and then goes back to rest and then a lowest point and then back again over and over again. So when we're dealing with harmonic motion, we change our basic formula just a tiny bit. Really all we're changing are the variables. So for example, if we're doing a sine graph that's modeling harmonic motion, we still have the amplitude in the front. That's how high and how low it goes. And we think of that, the distance, up and down distance, is called the displacement. And we'll talk about that in a little bit. And A would be the maximum displacement, the very farthest it ever goes from being at rest, either up or down. Then where we normally have a B after sine, now we have this kind of extra curvy W, which is the Greek letter omega. And then T stands for time, where normally we would have had an X there. So we're measuring off cycles during time periods. So the period where it was 2 pi divided by B before, now it's going to be 2 pi divided by omega. And that stands for the time it takes for one complete cycle, for example, for this spring to go up to its highest, down to its lowest, and back again. And then the frequency is the number of cycles for a given period of time. And the frequency is the period flipped over. So frequency and period are the flipped over of each other. Period is 2 pi divided by omega. Frequency is omega divided by 2 pi. And of course, all of this is also true for cosine, and a negative out in front will still flip the graph over. So we have y equals 3.2 cosine of 0.3 t, and we want to find the amplitude, the period, and the frequency of the motion that this is modeling. The amplitude is still the number out front, so the amplitude is 3.2. The period is 2 pi divided by omega, which is always the number in front of the t. So 2 pi divided by 0.3. Now we're dealing with decimals. We're not going to keep the pi anymore for these problems. Just put in your calculator 2 times pi divided by 0.3, and that's 20.94. And that's how long it takes, and I'm going to assume seconds here. That's how long it takes for one cycle, 20.9 seconds. And we're going to have to graph. So you still, for the scale, you still multiply by a fourth, by a half, and by 3/4 to get the scale. And that gives us 5.24, 10.47, and 15.71. Then the frequency is the period flipped over. So it's going to be 0.3 divided by 2 pi. You flip it, which is 0.05. So that's the number of cycles in 1 unit of time. Now they want us to sketch the graph. It says sketch the graph of the displacement over one complete period. Now, because time can't be negative, we only have to do the right half of the graph. We've got time, and y is the displacement. It's up and down motion. So we'll mark off our scale, 5.24, 10.47, 15.71, and finally 20.94. And then the highest it's going to go is 3.2. That's the amplitude. The lowest it's going to go is negative 3.2. It is a cosine graph, so cosine always starts up at the highest point when you're at 0. When time is 0, time is just starting. And then it crosses, lowest, crosses, and highest. Now this problem says find a function that models the harmonic motion. having the given properties. Assume that the displacement is at its maximum at time equals 0, and then they've given us the amplitude and the period. So they've given us the information you normally get from the formula, and we have to come up with the original function. So let's look at some of the things they've given us. The displacement is at its maximum at time equals 0. That means when you're at 0, the graph is at its highest point. Well, the graph is at its highest point at 0 if it's a cosine graph. When time is 0, sine graphs are also at 0. But cosine graphs, when you start up at the highest. So we know it's a cosine graph. The amplitude is 60, so that's A. And let's kind of write down what we're looking for. Y equals A cosine omega t. So we've got to figure out A, we've got to figure out omega. Well, the way you figure out the period normally is it's 2 pi divided by omega, and you work that out and you get a value. We have the value. It's 0.5. So we're going to write 2 pi divided by omega equals 0.5. Now multiply both sides by omega. 2 pi equals 0.5 omega. Divide both sides by 0.5. And then you would just put that in the calculator, and omega comes out to be, and I'm going to leave the pi. I'm just going to do 2 divided by 0.5, which is 4. And then let's put the pi back on. So now we have omega. Now we can fill in our formula. Y equals, the A value is 60, cosine omega, and then you just put the t. So that one's finished. Make sure you look at your notes for some homework help, because there are several little clues for you there.